Okay, question 2 of the 2023 General Maths exam here in South Australia. It's a statistical models question. It says the waiting time for non-critical patients to be attended to in an emergency department of Hospital A are found to be normally distributed with a mean of 3.4 hours and a standard deviation of 1.1 hours. Part A asks us to calculate the probability of a non-critical patient having a waiting time between 3.4 hours, the mean, and 4.5 hours, which is exactly one standard deviation above the mean. We know, well, some of us should know from experience that the answer is going to be approximately 34%, but let's actually work that out using the graphics calculator here. So we're looking for probability that a patient waits between 3.4 and 4.5 hours. So that's our notation. Then on a graphics calculator, we head into our stats function and we're looking at distribution. So F5, normal distribution, F1, normal cumulative distribution, so F2. And we are, rather than using a list, we're going to put in some variables. We're going to put in those parameters for the mean, which was 3.4, and the standard deviation, which was 1.1. And our boundaries, our lower boundary will be 3.4. and our upper boundary will be 4.5. Obviously, once those parameters are in, we can just toggle down here and execute or calculate, but I actually like to draw it as well so I can visually see that. You can see that our boundaries, as we said, were the mean in the middle there and exactly one standard deviation above the mean. So the probability is equal to 0.341. So 0.341 is the probability that a patient will be waiting between 3.4 and 4.5 hours. Part B says, in 1 month, 5,500 people were attended to in the emergency department. How many of those would be expected to wait more than 2 hours? So here we're looking at what's the probability that someone waiting, let's say X, is going to be greater than 2, okay? So we just hit exit on our graphics calculator. We're just going to change a couple of these parameters in terms of the boundary. So our lower boundary now is 2 hours, and our upper boundary we want to make as high as possible. So we just pop in 1 times 10 to the power of 99, make it as high as possible, and then we just go down and again draw that, and you can see there's sort of 2 hours as the lower boundary, and the probability that someone's going to wait more than 2 hours is 0.898 or 89.8% of those patients will be waiting more than 2 hours. So how many exactly is it? Because that's what the question asks, how many people? So we use that probability now, so 0.898, and multiply that by 5,500. Now I've already gone away and done this. Now remember, you would round it down to the next person, which works out to be 4,941. Okay, remember you can't have part of a person, so always round that down, not up. Even if it was 4,941.7, we round down, okay? So that's how many people are expected to wait more than 2 hours, okay? And that's your 2 marks for working out the probability, and then obviously working out how many people that correlates to. Okay, moving on to the next part here. C, a study estimates that 29% of non-critical patients who experience longest waiting times are more likely to experience complications in their recovery. Calculate the shortest waiting time for a patient who would be more likely to experience complications in their recovery. So here we're actually working out a time given a percentage or a probability here of 29%. Okay, so this is where we're talking about those quantiles, all right? So what we're going to do is we're going to actually head out of this on our graphics calculator, and we'll head back into distribution, normal distribution, but this time we're looking at the inverse of normal, okay? And I guess before I go any further, maybe if we sort of visualize it a little bit, like here's our normal distribution curve here with our mean of 3.4. We're looking at the top 29% of patients, all right? So we're kind of looking for this tail here on the right-hand side and what that boundary there sort of correlates with, okay? So what is the value there? What is that quantile we call K, all right? So I guess the notation that we'll be using here is the probability that x is greater than k is equal to what? On our graphics calculator, our tail will be on the right, as we can see here. So change that to the right. We're working out the area for 29%, so 0.29. And we're keeping the standard deviation and the mean the same as 1.1 and 3.4 respectively. So if we just toggle down now again and ask it to calculate for us, it will tell us that the answer is I guess rounded to 2 decimal places, 4.01. Okay, so the shortest waiting time for a patient who is more likely to experience complications is 4.01 hours. Okay, so hopefully you're seeing 2 before 4 hours or 4.01 hours. Moving on to the next part of this question, it's got here another hospital. So this is Hospital B. They also found to have normal distributed data with a mean of 2.1 hours and a standard deviation of 0.7 hours. The first part of this bit of the question says Hospital B claims that 25% of non-critical patients will be attended to within 1.5 hours. Using appropriate calculations, state if this claim can be supported. So what we're looking for here is the probability that someone can be seen to in less than 1.5 hours. And what is the probability of that? And obviously it needs to be, or based on this claim, it needs to be about 0.25. So let's head back out again. We're going to head back into distribution, normal cumulative distribution, and we're going to change those parameters this time for Hospital B. So Hospital B, the mean was 2.1, so let's go ahead and change that to 2.1 here. The standard deviation was 0.7 for Hospital B, and in this case, my upper boundary is going to be 1.5, and my lower boundary is going to be set to minus 1 times 10 to the power 99. Okay, so making that value really, really small. Again, let's go toggle down and draw that one. And there it is. We have probability is equal to approximately 0.195, which is 19.5%, which is less than the claim of 25%. Okay, so therefore the claim cannot be supported. Because only 19.5% of patients are seen under an hour and a half or under 1.5 hours, and the hospital is claiming that it's actually 25% of the patients that are seen under that 1.5 hours. So based on the data we have, that claim is not correct. Moving on to the next part here, it's got a diagram that shows the probability distributions of waiting times for those 2 hospitals we've already looked at, Hospital A, Hospital B, but also this new hospital here, Hospital C. It says, what are the mean and standard deviation for the waiting times for non-critical patients to be attended to in the emergency department of Hospital C? Tick the appropriate boxes to indicate your answers. So Hospital C, here is this, this line here. So if I head to the middle of that, that will indicate the mean. So around about here, which is just above 2, and you can actually see that it's got the same sort of mean as Hospital B, which was 2.1. So the mean for Hospital C is 2.1. And you can see that the height of this graph for Hospital C is the same height as the graph for that of Hospital A. So you can, from that, conclude that they actually both Hospital C and Hospital A have the same standard deviation. Now, remember back, Hospital A had a standard deviation of 1.1. So my standard deviation for Hospital C is also 1.1. Okay, and there's your 2 marks for that question. The last part here says, from the probability distribution diagram above, the following statement can be made. It is statistically possible for a non-critical patient to be attended to with less than 0 hours of waiting time. And in fact, if you look at this hospital C, you can see that this section here represents waiting time of less than 0 hours. Okay, so it says state why this statement, or state why this statement is unreasonable. Now, it's unreasonable because we can't have a waiting time less than 0. Okay, so that's pretty much it for the mark there. Cannot have a waiting time less than 0. Okay, we can't, I guess, attend that patient before they've even arrived at the hospital. Okay, so we cannot have a waiting time less than 0. It needs to be a positive value. And that's it for question 2 of the, that's it for question 2 from the 2023 General Maths exam.